Let me show the testing of EB1200 shortwave power amplifier with the MRFX1K80 LDMOS transistor inside and touchscreen LCD. The LPF band switching can be made manually, but it is better to use the automatic mode with the external band decoder as we do. The drain voltage is supplied by flat pack 2, 53 volts. This is a couple of dumb milliwatts, 50 and 25 ohms. The reference power meter is BERT43 with element for 2500 watts on shortwave bands. 2.5 kilowatt full scale, and I will drive it with the IC transceiver with the automatic band decoder. The internal power meter is calibrated on 20 meters according to BERT. Let me show. 1000 watts, same as here. Well, then I will raise the driving power. The normal is a 65 up to 70 watts. Let me show with the 70 watts. I will start from 160 meters. Tuning. Next is 80. Then some CW manipulation. Then SSB. 1, 2, 3, 4, 5. All. Okay. Let me return to packet mode and the central frequency on shortwaves, 20 meters. Now I will replace the dummy load from 50 to 25 ohms. If I try to transmit, highest double air protection will be enabled. To reset it, I have to switch off the 50 volts. Wait a little bit to discharge the capacitors and return the 50 volts. But if I go down with the driving power, amplifier is working with the half of power, and with this quite high SWR, but if I increase it slightly above the 40 watts, protection will be enabled. Okay, switch off the 50 volts and replace the dummy again by 50 ohms. Well, if I occasionally drive more than 70 watts, for example 90, high power protection is enabled on this band. Other band could be another kind of protection. Let me see. Again, high power, it doesn't matter. It has a high current protection, and when the temperature will rise up to 65 degrees, high temperature protection will be enabled too. I will not heat it up to this temperature. Well, reduce the drive to 70 watts and show that everything is okay.